real numbers is okay. I can do that.
Okay, real numbers. Then polynomials I have covered, pair of linear equations, quadratic, arithmetic progression also we have done. So don't worry because you have joined late. So we will try to cover it up for you again. Then triangles in this particular batch I'm telling you. So triangles I have already done. And coordinate geometry, introduction to trigonometry, applications of trigonometry. This much we have already done.
Okay, mom.
So only the last chapters are remaining, like circles and surface area and volume statistics and probability.
Okay.
So in your exams, I think, so which chapter you have not done in the school also, please tell.
Trigonometry.
Okay. And triangles have you done?
Yeah, we did. We started triangles.
Coordinate geometry?
Yes, we did.
Tell me one thing, like presently your school are off, right? So can I have a class in the morning tomorrow with you?
Yes, mom. Which chapter?
I think trigonometry, but it is not coming in the exam right now.
I don't know.
In your coming exam, a real number will come, right?
Yes.
Polynomials will come.
Yes.
Okay. Pair of linear equation in two variables.
Yeah, that will also come.
That will also come. Quadratic equation. So I think first of all, I should stick to your exam syllabus.
Yes.
So I'll take one of the chapter. We will do that.
Okay, mom.
Okay, just keep your syllabus ready for tomorrow. Now I have another class. So
okay, mom. Bye.
Bye. Okay. Yes, Hamna, can you hear me?
Yes, ma'am.
Okay. So Hamna, in the test, your performance was good, but only 2 questions you have not. Yeah, 1 question you have not attempted, right? Or you missed it. I don't know. Third part and fourth part. Yeah, this was wrong. So let us do it till Harsha joins. Question number 2, third part, Hamna, right? This was 4x square minus 2 into a square plus b square x plus a square b square is equal to 0, right? You have to solve it by factorization method. So in this question, you first of all open the bracket. So you get minus of 2a square x, right? And then plus minus minus 2b square x plus a square b square is equal to 0. Now here I can take something common. So for first 2 terms, take 2 into x common. So 2x and minus a square, right? Now I take minus b square common. So I get 2x minus a square is equal to 0, right? So 2x minus a square into 2x minus b square is equal to 0. So 2x minus a square is equal to 0. That gives you x is equal to a square by 2. X is equal to b square by 2. Is that okay?
Ma'am, can you explain the fourth part as well?
Fourth, right? Okay. Fourth part, I think you have not done or some mistake you have done. So 1 upon a plus b plus x is equal to 1 upon a plus 1 upon b plus 1 upon x. So take x terms one side, then start solving. Plus x and then minus 1 upon x, right? Equal to 1 upon a plus 1 upon b. This way also you can solve, but it's better to take all the x terms one side. Now take LCM. So a plus b plus x and into x is the LCM. So it will become x minus a plus b plus x is equal to ab, right? And then b plus a. Now open the bracket. So x minus a minus b minus x divided by ax plus bx plus x square is equal to b plus a divided by ab. Now this x cancels out. So I can take like minus common, a plus b divided by this thing, ax plus bx plus x square is equal to b plus a, or a plus b, I can write it. Right, so basically these terms cancels out. Do cross multiplication. Minus of ab is equal to plus x square, right? Now take everything one side. So ax plus bx plus x square and plus ab is equal to 0, right? X square plus ax plus bx plus ab is equal to 0. Just in the standard form I have written. From first two terms, take x common plus b. So x plus a is equal to 0. X plus a into x plus b is equal to 0. That gives you x plus a is equal to 0. Okay. The simple calculation is there. Just take LCM and do cross multiplication. Rest of the questions you have done correct. I think Harsha is not joining today. So Hamna, would you like to have a revision of any previous chapter, or should I proceed with surface area and volume? Yes, Hamna, is there any question? And one thing I want to ask you, Hamna, like why are you not doing assignments? Please unmute yourself.
Ma'am, they didn't upload any assignments on the portal.
But Harsha is submitting assignments on the portal. Either you try, I mean, as I told you that the assignment remains active only for 2 days, right? So if you are going to access it after 2 days, it will not remain active. Okay, I'll do one thing, Hamna. At least I'll try to send the assignments to you on the WhatsApp. Please try to solve all the questions. So that will help you to understand wherever your understanding is lacking or you are making mistakes, so that we can have a revision of that particular topic. So let us proceed with the chapter we were doing, surface areas and volumes. Okay, which question we have done? Third question I think we have covered. Now the fourth part, right? Fourth question. Exercise 13.1 we are doing. A cubical block of side 7 centimeter is surmounted by a hemisphere. So you have a cubical box, first of all. Right? Is surmounted by a hemisphere. So on the top of it, so there's a hemisphere like this. Understood? So it's difficult to draw because hemisphere is three-dimensional, but on the top of it, it is. Obviously, it's like this. Right, like this. What is the greatest diameter of hemisphere we can have? Now, cube is having a side 7 centimeters. So what will be the diameter of hemisphere? Greatest diameter? Diameter is this, right? From here to here.
Yes, ma'am.
So the greatest diameter it can have will be equal to the side of the cube, isn't it?
Yes, ma'am.
Yeah. So it is given that edge of cube is equal to 7 centimeter. So greatest diameter of hemisphere can be equal to 7 centimeter. Okay. Find the surface area of the solid. Now you want to find the surface area. So in reality, like it looks like this, something like this. It's actually difficult to draw because it's a three-dimensional figure. No, I hope you are understanding it, right, Amna?
Ma'am.
Yeah. So you have to find the surface area. So we can break the figure into two parts, like cube and plus hemisphere. So first of all, we will find the surface area of cube and then the surface area of the hemisphere separately, and then we will combine it to find the surface area of the figure. Surface area of hemisphere, first of all, what is the formula? So complete sphere is 4 pi r square, and this becomes 2 pi r square, right? Just half of the sphere. So you put the values. So 2 into 22 by 7 into radius. Now the diameter is 7 centimeter. How much is radius? 7 by 2, right? Into 7 by 2 because it is r square. So 1, 7, 7 cancels out. 1, 2, 2 also cancels out. Sorry, it was 2. And then 2 into 1 and 2 into 11. So I get 77 centimeters square. Is that okay? Now we come to surface area of cube. Now it is a cube, so simple length cube, right? Sorry, it's surface area, not volume, right? So 6 into area of each face, that is L square, 6L square or 6A square we call it. So that is 6 into length is 7 centimeter into 7 centimeter. So that becomes how much? 6 into 7 is 42 and 42 into 7 is 14, 294. So 294 centimeters square, right? Now what will be the total surface area of the figure? Yes, Hamna. Please unmute yourself, Hamna. Hamna, you have to unmute yourself, right? This way, how will I able to teach you? Okay, your mic is unmute, but I think I cannot hear you. Yeah, your voice is not coming, Hamna. Please speak up something. Okay, there's some problem is there, I think. Now try to understand one thing, Hamna. If I want to find the surface area of the figure, right? The given figure. So it will be like surface area of cube, right? Plus surface area of hemisphere. Hemisphere, right? But this is not the correct answer. It will not be equal to this. Why? Because this was cube, right? This was cube. So how many faces it is having? It is having 6 faces. Okay. Now on one of the face, you have a hemisphere plotted. So hemisphere base is actually circle. So let's say this is the face or top face of the cube. And then there's a hemisphere whose base is a circle. So this much of the area goes inside the hemisphere. So it will not be added up in the surface area. But these corners which are remaining, you will be able to see them. So they will be counted in the surface area of the complete figure. Is that clear? Okay. So that means because this complete face you have already included in the formula. This face was already there. You only have to subtract this much portion. This circle portion you have to subtract because you're not able to see this. So you have to minus area of the base of hemisphere. Understood? So you have to visualize the figure. So that means surface area of cube we have already found, that is 294 centimeters square, plus surface area of hemisphere is 77 centimeters square, minus area of the base. Base is a circle whose area is pi r square. So minus pi into r square. Again, the radius will be 7/2. So pi r square, right? So you can write it in the next line here. So this will be like 294 centimeters square plus 77 centimeters square and minus pi is 22/7 into 7/2 into 7/2. So 7 cancels out. This is 11. 77/2. So 294 plus 77 minus 77/2. So just add them. 7 and 4 is 11. Then 1, 10 and 17 and then 1, 3. Please check the calculation if I have done it correct. Divided by 2. So either you divide first and then subtract, or you can take LCM and then do division, up to you. So 2 into 1 is 2, 2 into 7 is 14, 742 minus of 77. So that gives you 12 minus 7 is 5. And then it gives you 13 minus 7 is 8, 6, right? And then you have 6 here. So that gives you 332.5 centimeters square as the area. I hope it is clear. Okay, next question. Question number 5. A hemispherical depression is cut out from one face of a cubical wooden block such that the diameter L of the hemisphere is equal to the edge of the cube. Determine the surface area of the remaining solid. Similar kind of figure, but this time what is happening is, let's say you have a cube again. So this time the hemisphere is not on the top, but it is actually like this inside it. Understood? So on the top, this is the base of the hemisphere, which you can see. And the diameter of this hemisphere is actually equal to the side of the cube. So exactly touching the cube from all the 4 sides. And then it's like a ball fitted inside a cube. It's like that. You have to find the surface area of the figure. Okay, so surface area of the given solid or figure, you can call it. So it will be surface area. In short, I think I should write SA. So surface area of cube, right? Plus. Now, because this hemisphere is inside, so this inside inner surface area of the hemisphere will be added in the surface area of the given solid, right? Because you are able to see the inner surface area of the hemisphere in this figure, plus inner surface area of hemisphere. Understood? Minus. Now, obviously, this top face of the cube is gone, only the corners are remaining. So that means you have to subtract this base of the hemisphere. So minus area of base of hemisphere. Because in this formula, you have included the full face of the cube, but you are not able to see the full face. So you have to subtract the area of the base of the hemisphere. Only these corners you can see. Now put the formula. Surface area of cube, that becomes 6L square, and plus inner surface area of hemisphere is actually surface area of hemisphere, which is 2 pi r square. R is basically L by 2 whole square, right? And minus area of base of hemisphere, which is pi r square. So pi into r is L by 2 whole square, right? You can write like diameter is equal to L here. So radius becomes L by 2. Now just simplify. Can I take just L square outside just to make it a bit simple? So 6 plus, it will be 2 pi divided by how much? 4. And minus pi, L square is gone, divided by 4, right? Am I right? Okay. So my L square is outside, so that becomes 6. Now 2 pi by 4 minus pi by 4. So only pi by 4 will remain, isn't it? Let us try to solve it this way. So that means L square, okay, L square, and you take LCM here. So 4, 6 into 4 is 24, and plus pi. Now you put the value. L is it given in the figure? No, it's not given. So you have to tell in terms of L only. So answer is this, L square by 4 into 24 plus pi. Of course, centimeter or unit, because nothing is given. So unit square. Because this is area you are finding. So area will be in unit square, okay?
Okay, ma'am.
All right, next question. Sixth. Now, a medicine capsule is in the shape of a cylinder with 2 hemispheres struck to each of its end. So you have seen a capsule, right? It looks like this. Then it is like this. So basically, like up till here, you have cylinder, and then there are 2 hemispheres on each side. The length of the entire capsule is 44 mm. 14 mm. So 14 mm is the length from here to here, right? From here to here. And the diameter of the capsule is 5 mm. So from here to here, this length is 5 mm. Find its surface area. So its surface area is simple, like, okay, how will we find the surface area? Okay, first of all, diameter of hemisphere or of the cylinder also, so it's simply write diameter is equal to 5 mm. So your radius will be 5 by 2 mm here. Okay, same for both hemisphere as well as cylinder. Radius is 5 by 2 mm. Now the surface area of the capsule. Now try to understand this thing. Will be 2 into area of hemisphere, right? Surface area, not area. Surface area of hemisphere. Clear, Hamna?
Yes, ma'am.
Okay. Plus surface area of cylinder. Should I subtract something from here? Can you tell me what?
Ma'am, the base of the hemisphere.
Yes. So we will do one thing. If we are subtracting the base area of hemisphere, so for cylinder, we can only calculate curved surface area, right? Because in the cylinder also, there is this area, right? Isn't it?
Yes, ma'am.
So if we take total surface area, then this area will also come. But we don't want this area, so we will stuck to only curved portion. So here we will take curved surface area of cylinder, right? And obviously hemisphere, we are taking total surface area, that is 2 pi r square. So we need to subtract the base area. So 2 into base area of hemisphere. So that will give you the surface area of the capsule. Simply put it now. So 2 into surface area of hemisphere, that is 2 pi r square, plus curved surface area of cylinder is what? What is the formula? 2 pi r h, right?
Yes, ma'am.
Into height. And then minus 2 into base area of hemisphere, which is a circle, so pi r square. Now you don't know height of the cylinder. So what is the height of the cylinder? In this case, height or length, you can call it in this case, height of cylinder is equal to. Now total length is 44 mm that you can see, right? Now this much is actually the radius of the hemisphere from here to here. This is also radius of the hemisphere, isn't it?
Yes, ma'am.
Okay. So you can like radius plus radius is actually one diameter. So basically you have to subtract like 14 minus 5 by 2 plus 5 by 2, that is 5. So 14 minus 5. Is that understood?
Yes, ma'am.
14 minus 5 by 2 and then again minus 5 by 2. So that is 14 and minus of, you can do 5, which is how much? 9 mm. So put here, that is 4 into pi r square, means 22 by 7. R is 5 by 2 into 5 by 2 plus 2 into 22 by 7 into R is again 5 by 2. H is 9 by 7 into 5 by 2 into 5 by 2. Now you solve all the terms. So just to make it a bit simpler, I can take like 22 by 7 outside. And I think 1, 2 also I can take outside, right? And 1, 5 by 2 also I can take outside. You can do it directly, just the way you like it. So inside here, 2 into 5 by 2 is remaining, plus 9 is remaining, minus then only 5 by 2 is remaining. Depends upon how you want to solve it. So outside I have like this is 11 times. So again, I have to multiply. 2 into 5 is 10. 10 into 11 is 110 divided by 7. And then inside I have 2 and 2 gone. So I have 5 plus 9, that is 14 minus 5 by 2, right? So 110 divided by 7 into 2 into 14 is 28 minus 5 is 23 divided by 2, right? I hope I have done the calculation correct. So 2 into 1, right? 2 into 5 and then 10, 55. Multiply 55 by 23. I think something wrong I have done with the calculation. Are you also getting the same thing, Amna?
No, ma'am.
Yeah, I think I have done because it's not divisible exactly. Let me do it here itself. So this 2, 2 and 4 are gone, right? This 2 and this 2 is gone. Similarly, this 2 and this 2 is gone. So at least 22 by 7 I can keep outside. So I have 5 into 5, 25 by 7 plus 5 into 9 is 45 minus 5 into 5 is 25 divided by 2. So far, is it correct? This is 22 by 7 into 7 and 2 is 14 LCM I'm going to get. 50 plus 45 into 14. $630 minus 175. Okay, this I'm getting. Great. 505. No, Amna, I think again I have done some mistake in the calculation. Okay, let us just check again. What is the answer you are getting, Amna? Okay, let us just check it again. So surface area of hemisphere will be 2 pi r square, right? So we are multiplying that by 2. So this is fine, right? And then curved surface area of the cylinder is 2 pi RH. That also fine. And this is area of oh, what my mistake I'm doing Hamna here is now try to understand Hamna. This term is not required, isn't it? Why? Please see, this term is not required here because it's a hemisphere. A hemisphere looks only like this. And we are actually taking only the curved surface area of the hemisphere in the formula. This is curved surface area. The total surface area of hemisphere is actually 3 pi r square. Understood? That
Yes, ma'am.
means the curved surface area and plus area of the base, which is again pi r square. So we are not taking the total surface area. So we are initially taking only the curved surface area. So that is 2 into 2 pi r square, right? And for cylinder also, we are taking only the curved surface area. So there is nothing which has to be subtracted. Understood?
Yes, ma'am.
Oh, that was the mistake we were making. So I think now you will be able to solve it. 22 by 7 into r square, that is 5 by 2 into 5 by 2 plus 2 into 22 by 7 into r is, that is 5 by 2. H is how much we found? 9, right? Yeah, that was 9 mm, the length of the cylinder. Now simply this 2 goes out. This 2 goes out. Now please solve it. I'm leaving. Okay. See, this way you make it easier. You can see 22 by 7 into 5. You can take outside. So here you are only left with 5 plus 9, right? Right? Okay. So now you multiply this thing. So 5 into 2 is 10. 110 divided by 7 into 9 plus 5 is 14. So 7 into 1, 7 into 2, and 2 into 0, 220. So 220 mm square is the answer. Otherwise, you have to do all the multiplication, then addition. So you can take something common and solve. Right? Okay, next question. Question number 7. A tent is in the shape of a cylinder surmounted by a conical top. So there is a tent which is like this. So this is a cylinder here, and then you have a cone on the top. This is the shape of the tent. If the height and the diameter of the cylinder are, so the height of the cylinder is given something from here to here, which is 2.1 meter, and the diameter of the cylindrical part, so that means, this is the diameter. So from here to here, it is 4 meter respectively. And the slant height of the top is 2.8. So in this case, like this slant height, so if I just draw it like this height from here to here, this is 2.8 meters. Find the area of the canvas used for making the tent. So that means total surface area of the tent you have to find, right?
Yes, ma'am.
Okay, now surface area of tent. First of all, what will it include? It will include only the curved surface area of the cylinder because we don't want the area of the base. This is at the ground. So here canvas will not be required. Understood? So canvas will be required here only. So we take only the curved surface area of the cylinder. Fine, plus. Now you come to cone. So we take only the curved surface area of the cone, right? Because again, here the canvas is not required. Canvas is required only here. Understood? So curved surface area of cone. So this will be the total surface area of the figure. Now, what is this equal to? This is equal to 2 pi r h and plus curved surface area of the cone is pi r L, right?
Yeah.
L is the slant height. So from here you can see, okay, take pi common. So 2 r h and plus, okay, r also common. So 2h plus L, right? Now put the value. So 22 by 7 into radius. Radius will be 2, right?
Yes, ma'am.
Okay, and 2 into h. So 2 into height is 2.1 meter and plus L. Slant height is 2.8. So that becomes 44 divided by 7 into, you multiply and then add. So 2 into 1 is 2, 4.2 plus 2.8. 10 and then 670, right? 7.0. Is that clear? 8 into 10, yeah. Okay, so basically 7 goes out. So 44 meters square only is the answer. I mean, is the total surface area of the canvas. Now, also find the cost of the canvas of the tent at the rate of rupees 500 per meter square. So for 1 meter square, cost is, for 1 meter square, cost of canvas is equal to rupees 500, right? So for 44 meters square, the cost of the canvas will be rupees 500 multiplied by 44, right? So just multiply, so 2 zeros, 5 4 are 20, and then 2, so 22000 rupees will be the cost. Okay, I hope you have done it. 8th question now. From a solid cylinder whose height is this and diameter, a conical cavity of the same height and same diameter is hollowed out. Okay, so you have a cylinder like this. Right. Now, this is the height of the cylinder. So from center to center, this is the height. And this is the radius or diameter. A conical cavity of the same height and same diameter is hollowed out. So basically, this area of the base of the cylinder will be same as the base of the cone. Okay, same diameter. And the height of the height of the cone is also same. So it will reach its another face. Find the total surface area of the remaining solid to the nearest centimeter square, right? Yes, Amna. So can you tell me what will be the surface area of this solid? Okay, now we have to break the figure. So surface area of the solid will be how much? First of all, we have to take the curved surface area of cylinder, right? So curved surface area of cylinder. Now plus. So from outside, it is looking like cylinder. And if you look inside it, so you will be able to see a cone, right? So that means you are able to see the inner surface area of the cone. Inner surface area of cone. Is that okay?
Yes, ma'am.
Right. And yeah, what else is there? In the surface area, see, this is a cavity. That means there is nothing here. It is open from this side. Understood? So there is no area, like there is no area here. This is hollow. But the solid is having a base also, isn't it, Hamna?
Yes, ma'am.
So the base area will also be counted. So plus base of cylinder. Because we have taken only the curved surface area. If we have taken the total surface area of the cylinder, then we have to subtract the base of the cone in that case, right? Now simply put the formula. Curved surface area of the cylinder is 2 pi r h, okay, plus inner surface area of the cone. That means the surface area of the cone, which is 2 pi r l, right? No, sorry, pi r l only, not 2 pi r l. And plus base of the cylinder, that is pi r square. So now in this question, what is given here? H is given, which is 2.4 centimeter, and a diameter is given, which is 1.4 centimeter. So you can write the radius, which is 0.7 centimeter, right?
Yes, ma'am.
But we don't know L here. First thing is to find L, right? Now L, we know that L is equal to H square plus R square. Is that okay? I gave the formula. So you put the values here. H is 2.4 whole square plus radius is 0.7 whole square. That is equal to, you can remove the decimal first and then solve it if you wish. So 24 by 10 whole square and plus 7 by 10 whole square, right? How much is 24 into 24? Please check. 4 into 4 is 16. 576. This is 576 divided by 100 plus 49 divided by 100. So that means 100 is the LCM. That is 576 plus 49, right? So that is 6 and 9 is 15, carry 1, 8 and 4 is 12. Then it is 625 divided by 100. 625 is a perfect square of 25, right? This is 25 into 25 is 625, am I right? This is 25 divided by 10, which is actually 2.5 meter or centimeter. So that is the slant height L, okay? .5 centimeter. Now you will put it in the formula. So I'll not do the calculations. Here you can see, Hamna, I can take a pi outside at least, and then 1 r I can take outside. So I'm left with 2h, right? Plus pi r outside, so L plus only r. So that makes the calculation a bit simpler. So I'm erasing it. That is 22 by 7 into r is 0.7. So I'm writing it 7 by 10 directly. And then 2 into h is 24. So I'm writing 24 by 10 plus L is 2.5. So 25 by 10 plus r. R is again 0.7. So 7 by 10 I'm writing. So there's no harm. Otherwise, you just do the decimal calculation. That's it. Now 7 cancels out. So this is only 22 by 10. Then you take LCM, which is 10. So 2 4s are 8 and 2 into 2 is 4. 48 plus 25 plus 7. So that is 22 by 10 into, now please add. How much is it? 48, 25 and 7. So 8 and 5 is 13 and 7 is 20. 80 I'm getting here. So 80 divided by 10. So at least 1 0 will go out. So this is 8 into 2 is 6. Carry 1. 176 divided by 10 and that becomes 17.6 centimeters square because this is area, so centimeter square. Okay, one last question of the exercise. Let us complete it. 9th question. A wooden article was made by scooping out a hemisphere from each end of the solid cylinder. So you have a cylinder. It looks like this. Right. Now from each end, you have scooped out. Scooped out means inside like this. One hemisphere you have removed and similarly from this side. Understood? You have removed. If the height of the cylinder is 10 centimeter, so 10 centimeter is the height from here to here. And the base is of radius 3.5 centimeter. So this radius is given from here to here. You have 3.5 centimeter. Find the total surface area of the article. Now in this case, what will be the total surface area of the article? TSA of the article will be. So curved surface area of cylinder, right? Plus. Now because you are able to see the hemisphere inside, like if you look at the cylinder inside, so you will be able to see a hemisphere. So plus inner curved surface area hemisphere. And because there are two, so you can multiply this thing by two, right? One top and one bottom. So that's all you will be able to see here. This is 2 pi r h and plus, so 2 into inner curved surface area, that means 2 pi r square, right? Again, I can take 2 pi r common, only h will remain here, plus 1 2 will remain and 1 r will remain. Now put values. So 2 into 22 by 7. Radius is 3.5. So 35 divided by 10. Height is 10 plus 2 into 35 divided by 10. So 7 into 1 and 7 into 5, right? So 5 into 1 and 5 into 2. So this 2 gone. So only 22 remaining. And this is we take LCM. So this is 100 plus 70. That becomes 22 into 170 divided by 10. This is gone. So 22 into 17, which you can multiply. 7 into 2 is 14. 7 into 2 is 14, 15. 374, of course, centimeters square is the answer. Yes, Hamna? Okay, so this completes exercise 13.1. Now 13.2 we will do in the next class. I'll try to send one assignment also. Hamna, you're not submitting assignments. Why?